Alright, so air resistance is a force that can probably best be approximated by quadratic drag, and the force is just going to be some constant times the velocity squared. And we know that force is equal to mass times acceleration per Newton's second law, and so we know that acceleration is going to be equal to bv squared over m, where b is a coefficient of drag, minus g, and this is if we're defining down as negative. Now the problem with solving for v or x in terms of t is that this function has velocity as a variable, and so if we want a function of velocity or velocity as a function of time or position as a function of time, we're going to use separation of variables. So acceleration is just equal to dv dt. That's going to be equal to bv squared over m minus g. And so we're going to separate this dv on one side and dt on the other side and integrate both sides. But to make our lives easier, we're going to multiply both sides by m over b. And so we're going to have m over b dv dt is equal to v squared minus mg over b. Okay, so if we move, we want the everything with v on one side and everything with t, well, I guess that's just the dt on the other side. So what we're going to have is b over m dt integrated from 0 to t is going to be equal to dv over v squared minus mg over b, and that's going to be integrated from your initial velocity v naught to v. So in order to integrate this bad boy, we're going to probably use partial fractions, so this can be decomposed into a over v plus square root of mg over b plus b v minus square root of mg over b. Now this should look a little familiar. That's because that's a terminal velocity. So if you solve for when the force of gravity, mg is equal to b v squared, you get this v is equal to the square root of mg over b. And so later on, we're just going to refer to terminal velocity just v of t. It'll just save us some space. But so we need to find the two coefficients that will give us our original fraction. So a times b plus b times, or a times this plus b times that has to give us 1. Because there's no variable in the numerator and the only constant's a 1. And so we have AV minus AVT plus BV plus BVT is going to equal 1. Now V is a variable, and so we know that A plus B must equal 0. 0. So A is equal to minus B, or vice versa. But terminal velocity is just a constant. These aren't mg and b aren't variables in this context, and so we have that a plus b vt is equal to 1, and so a plus b is going to equal to 1 over terminal velocity. And we know that a is equal to negative b. So negative b plus b, it's going to be 0. Did I do that right? Oh. Right, okay, so yeah, this is a minus AVT. And so since A is equal to negative B, then we have 2B is equal to 1 over terminal velocity. And so we're going to have that B is equal to 1 over 2 for terminal velocity. and a is just going to equal negative 1 over 2 v terminal. Okay, so now we're going to have two different fractions that we can integrate under our integrand. Going to have the first one, and we can go ahead and integrate this. Here it's just b over mt is equal to integral from v naught to v of 1 over 2 vt v minus square root of mg over b. Or wait, no, we can just, yeah, we're just calling it terminal velocity. That's right. Minus 1 over 2 vt v plus vt. Okay, dv. And now what you'll notice here is that we can factor out a 1 over 2 terminal velocity, and we're just going to take that to the other side because that'll make our lives easier. And so we have 2 vt b over mt is equal to the integral from v naught to v of 1 over v minus vt dv minus the integral from v naught to v of 1 over v plus vt dv. So we're going to do a couple u substitutions here where actually we don't even really need to. This is just going to be 2 vt b over mt is going to equal natural log of v minus vt evaluated from v naught to v minus natural log of v plus vt, again evaluated from v naught to v. Okay, now if you remember properties of logarithms, then you know that if you subtract natural log value, it's the same as dividing top by the bottom. And so for this side, we're just going to have ln v minus vt over v naught minus vt minus ln v plus vt over v naught plus vt equal to vt b over mt. Now we can also combine these two natural logs, and so we're going to have ln v minus vt times v naught plus vt over v naught minus vt times v plus vt is going to be equal to 2 vt b over mt. Now this gives us a function of time, or gives us time as a function of velocity, but we want a function of velocity with respect to time. So we're going to need to find basically the inverse of this. We're going to raise both sides, or we're going to have e raised to both sides. And so we're going to have e to the 2 vt b over mt is going to be equal to v naught plus vt over v naught minus vt times v minus vt v plus vt. Okay, so we're going to go ahead and take this little term to the other side. I'll probably do it over here. So we have v naught minus vt, because v naught is again a constant. You want all our constants on one side and all our variables on one side. 2 vt mt is equal to v minus vt. Okay, and then to isolate the v's on this side, what we're going to have to do is multiply this side by the denominator, and then bring every term with v back to this side, factor out a v, and then divide by it. So this is kind of ugly, so we're just going to call it ugly. So v plus vt ugly is equal to v minus vt. Okay, so we distribute the ugly, v ugly plus vt ugly plus vt is equal to v. And so we have VT ugly plus VT is equal to V minus V ugly. And we're going to factor out a V on this side, so we get 1 minus ugly. And then the next step was we're just going to divide this side by that to get V by itself. So we get VT ugly plus VT over 1 minus ugly is going to be equal to V. Okay, so we're pretty much there. Okay, so we got V is equal to VT, V naught minus VT, V naught plus VT, e to the 2 VT B over MT plus VT over 1 minus V naught minus VT over V naught plus VT e to the 2 VT B over MT. And that's going to be our analytical solution. In a lot of cases, it just makes sense, or it makes more sense to use a numerical solution. But I think it's rather elegant that there is an analytical solution out there. But again, quadratic drag is still just an approximation. It's a pretty good one. But if you wanted an actual exact solution, well, then we'd have to find smooth solutions to the Navier-Stokes equations, which I don't think are going to happen anytime soon. In terms of simplifying this, trying to think about what I could I mean, that's probably as simple as it's going to get. Now, if we want position, I kind of tried solving for it using Laplace transforms, but I didn't know what to do with the Laplace of y prime squared. And so what instead I did was, since, okay, we know that A is equal to B over M, BV squared over M minus G. And we know that A is equal to dv dt, and V is equal to dx dt. And we solve both these for dt, and set them equal to each other. So dv over A is going to be equal to dx over V. And this is something that we can integrate if we move this V over. So we get dx evaluated from 0 to x, or actually no, x naught to x, because we may have an initial position, is going to be equal to v dv over, and we're going to do the same thing over here where we multiply both sides by m over b. Oh wait, no. If we're going to do that, we got to do it earlier. So m over b is going to be equal to actually, yeah, so this is, A is going to be equal to times B over M. Okay, B over M, V squared minus MG over B is going to be integrated from V naught to V. And again, we can factor B over M out, take it to the other side, so it's in the denominator, so when we take it out, it's just going to flip M over B, but when we take it to the other side again, it's going to be B over M again. X minus X naught is going to be equal to the integral from V naught to V of V dV, V squared minus MG over B. b. Now this is a lot easier to integrate because we can do a u sub. So we're going to set u equal to v squared minus mg over b. So then du is going to be equal to 2v minus, oh wait, no, that goes away because it's a constant, dv. Okay, so we're going to know what dv is. dv is equal to du or 2v. And so that's just, this integral just becomes 1/2 1 over u du. And when we integrate this, we get ln of u. And so this is, and might as well take this 2 to the other side anyway. So we got 2b over m is going to be equal to ln of v squared minus mg over b. And this is going to be evaluated from v naught to v. So again, using our property of logarithms, we can simplify this to x minus x naught. 2b over m, x minus x naught, is going to be equal to natural log of v squared minus mg over b over v naught squared minus mg over b. Okay, now this is going to be a lot easier to solve in terms of x, except for this last part where we have v as a variable. We're going to need to take our previous answer and substitute it into here. So if we want to solve for x, then we get x is going to be equal to m over 2b natural log of v squared minus mg, we're just going to call this vt squared, over v naught squared minus vt squared. Plus x naught. That's going to be our initial position. So if we want to do that, then we want to, in terms of t, which is what's most useful, we're going to have to take this and input that for v squared. So I have to square this bad boy. So we square the top and square the bottom, which, I think I'm just going to rewrite our equation for v. So v is going to be equal to vt, v naught minus vt, over v naught plus vt, e to 2vt, v over mt, plus vt, over 1 minus v naught minus vt, over v naught plus vt. Although luckily we only have 2 terms on both the numerator and the denominator, so it shouldn't be too bad. So if we're going to square this mother trucker, then we got vt squared, v naught minus vt over v naught plus vt squared. And if we square an exponential, we're just raising it a power, and so we can just multiply it. And so we're going to get an e to the 4 vt b over mt, and the middle term is going to be plus 2 vt squared from both these, v naught minus vt over v naught plus vt times e to the 2 vt b over mt plus vt squared, that didn't fit on the top, okay, over, if we square this, then I get 1 minus, again, 2 v naught minus vt over v naught plus vt, e to the 2 vt b over mt, and plus vt over v naught plus vt squared, e to the 4 vt b over mt. Okay, so that's just all of this is gonna end up going in there, and that's gonna give us our final equation. But I'm going to see what I can do to simplify this expression because it's pretty darn nasty. So what I think I'm going to do is I'm going to have, I'm going to multiply the top and the bottom by v naught plus vt over v naught minus vt, right, and you should see that this is just equal to 1, because when you divide it by itself, it gets 1. And so this is going to cancel one of these terms on each one, and actually we're going to call this u just for now, or u squared, or we're going to call e to the 2vt b over mt u, and the terms that have the 4vt is just going to be u squared. And so we're going to get vt squared v naught minus vt over v naught plus vt u squared plus 2vt squared u plus vt squared v naught plus vt over v naught minus vt. That's going to give us our numerator, and our denominator is going to be v naught minus plus vt over v naught minus vt minus 2 u plus v naught minus vt over v naught plus vt u squared. And then from here, I haven't actually done this whole bit before. What we could do is, if we want to simplify this further, actually, okay, we're going to forget we did this last little bit. Instead, we're just going to leave the bottom in parentheses and see if we can use synthetic division to get something out of the numerator. It's a little simpler. So I'm just going to rewrite this real quick. V naught minus Vt over V naught plus Vt squared, and we're going to again call this u squared plus 2Vt squared V naught minus Vt over V naught plus Vt u plus Vt squared. And this is going to be over 1 minus 2, wait, no, 1 minus V naught minus Vt over V naught plus Vt u, and this is going to be squared. Okay, so this is what we've got. This is, okay, rats. We're going to multiply the top and the bottom by V naught plus Vt over V naught minus Vt squared. Whoops. This is just so we can get a linear factor without a coefficient in front of the x, so we can use synthetic division. Okay, and so on the top, we're going to get Vt squared, u squared, plus 2Vt. The first one's going to cancel, so we get V naught plus Vt over V naught minus Vt u plus Vt squared. And this is all over Actually, we're going to factor out a VT on the numerator. Okay, probably make things a little easier. And then on the bottom, we're going to have V naught plus VT over V naught minus VT. What's that? Squared minus U. Wait, no. For factoring it into the I don't think that's technically allowed. So if you multiply that by and just to be sure, I'm going to double check here. Where was I? Yep, nope, this one page. Okay, so we expanded this. Multiply this by V plus VT or V naught minus VT. And I'll do the same on V naught plus VT or V naught minus VT. This is going to cancel with that. And this will be squared minus 2U. Okay, so I guess you can't do that, but it'll be similar enough. Oh, crap. We're going to have V naught plus VT over V naught minus VT squared minus 2U V naught plus VT V naught minus VT plus U squared. Okay, so we're just gonna have to refactor this again, which will just factor into U plus V naught, or no, U minus V naught plus VT over V naught minus VT, and this is just going to be squared. And you should be able to see why that is. Okay, so we're going to see if we can divide this out of the numerator, not counting the VT. So if you remember synthetic division, we got V naught plus VT. You take the solution, not the factor itself, in here, and you have each of your terms in descending order. And so we have VT as a coefficient here, and then 2 V naught plus VT over V naught minus VT is a term here, and VT is a term here. So what you do with synthetic division is you bring this down, then you multiply this by that, you get VT, V naught plus VT, V naught minus VT, and then you add these two, so you get 2 plus VT, V naught plus VT over V naught minus VT, and again multiply it again, you get 2 plus VT, and V naught plus VT over V naught minus VT squared. And add that, and you get 2 plus VT, V naught plus VT over V naught minus VT plus VT. Okay, so our new numerator is going to be VTU plus 2 plus
vt v naught plus vt over v naught minus vt plus 2 plus vt v naught plus vt over v naught minus vt plus vt over v naught plus vt over v naught minus vt. It's going to be our numerator, and because we divided it out, the bottom is just going to be u minus v naught plus vt over v naught minus vt. Yeah, that's right. So this simplifies a little bit. That and that'll cancel, and you can split it up into two fractions. So now remember, going back, our antiderivative was again right up here. X is equal to m over 2b ln v squared minus vt squared over v naught squared minus vt squared. And we were trying to simplify v squared, which coincidentally v squared minus g is going to be its derivative, because that's what we defined it as with our separation under this, which is just another interesting fact. So that's how you get the function for acceleration. But back to this beastie here. So we're going to have x is equal to m over 2b natural log of, we have vt e to the 2vt, wait, what was our u again? B over mt plus 2 plus vt, and I don't think distributing that is going to make that much simpler. The only way it would, I think, is if it canceled with a bottom, but we got two sets of linear or positive factors, so I don't think that's actually I think we're going to break this up into two fractions. It'll probably just be easier that way. E to 2vt v over mt minus v naught plus vt over v naught minus vt. And it's going to be plus 2 plus vt over v naught plus vt v naught minus vt plus vt. And with this, for dividing by this, you can just flop it, and so this term will just be 2 plus vt times v naught minus vt over v naught plus vt, and then plus vt. Well, that's obviously probably as simple as that term's going to get. But in terms of here, I think we could probably simplify it a little. I don't know how much simpler that'd be. Okay, so we're not going to get this down to one term, not unless we tried partial fraction decomposition, but I think that would probably just be more fuss than it's worth. Wait, where was I? Oh, I forgot the rest of this actually. And this is going to be minus vt squared. And then all this is going to be over v naught minus vt squared. But if we're dividing by, it's the same as multiplying by the inverse, or this whole thing's divided by. So each term divided by. It's the same thing as multiplying it in the denominator. So, in terms of simplifying this, we have our x superposition to be ln vt e to the 2 vt b over mt plus 2 plus vt v naught plus vt over v naught minus vt plus 2 plus vt over, wait, no, that's right, we're gonna flop this crap. So we have 2 plus vt. Actually, and these are like terms. I didn't realize that before. So instead, what we can do is we can have v naught minus vt over v naught plus vt. I can't believe I didn't notice that. We can just say that this is what we're doing. Plus vt minus vt squared. Oh, that's why I didn't do it before. Okay. Gosh dang it. And all this is going to be, okay, we're going to have times, I don't like that. That's an ugly fraction symbol, or whatever you want to call it. And then you have v naught minus vt squared, which I don't think we could, or maybe we can. No, we can't, never mind. Although I am kind of curious what that would evaluate to. And this is just going to be over v naught minus vt squared. And so plus x naught. And this is our function for position with respect to time of an object in free fall with air resistance. As you can see, it is not something that is easy. It's easy to do algebra with, and that's probably why they don't teach it most of the time. But anyway, that's how you would derive both the functions for position and velocity. And then for acceleration, you could do two things. You could take the derivative of velocity with respect to time, or what you could actually do is you could take b times v squared over m and subtract a g, and you'd also get a function for acceleration with respect to time. So yeah, hope it makes sense now why they don't teach air resistance to high schoolers or even a lot of college people, because a lot of times it doesn't make sense. A lot of times it's just better to use numerical methods to approximate this. So yeah, these are, I can't really get them in this frame at the same time, but yeah, these are functions. So yeah, thanks for watching.